That's why we are active thinking, and we plan to do more on this, and this will be exactly something which MDRF will be taking up. If I see a graph of a patient, and I'm just going to show you one, I can tell you whether it's type 1 or type 2 diabetes. This is not in the literature. It's not been described here. And just give you an example of that. Look at this. If you see somebody like this, whose graph is going up and down, it doesn't happen in type 2 diabetes. Type 2 diabetes you will get like you want to saw that second graph. Some yellows you will find, but you won't find a lot of reds. Here, with this particular graph, if I show it in another way, you can see the amount of red there is and how much of yellow there is within hours on the same day. So from low to high, within hours it's going low, it's going high, it's going low, it's going high. If you show me the graph, I say this is type 1 diabetes. I may be wrong, but 95% I'll be right if I see this. On the other hand, if I show you another graph like this, there's no low, it's only continuously high. So I'll say, hey, your diet has to be improved, maybe you're not active, exercising enough, I have to give you a little more medication, maybe I have to give you one more tablet, maybe I have to give you a little more insulin. Simple. This is type 2 diabetes. Okay? Now, I am saying this out of my previous experience and saying that looks like type 2 and looks like type 1. I'm only guessing. Can we put this into AI and can AI tell us with 99.9% accuracy that this is really type 1 and type 2? Nobody in the world has done this. This is what we're planning to do as one of the first things immediately that we are starting. Now, how do we do that? I don't know. I don't know what. I'm not a mathematician. I don't know how to do. Maybe the level of fluctuation, the number of low sugars, where do we draw the line? Obviously, type 1 is one end and type 2 is another end. There will be some in between who are more difficult. That is what AI will help to pick up. How do we, with about 95% accuracy, say that? You may say that there are other tests to use type 2 diagnose type 1, type 2. Well, there are tests, but there are a lot of tests. Some of them take days to come. This you put it in 3 hours, you know, or 4 hours, you know what is type 1 and type 2. Okay, which you would not have known by taking our old-fashioned SMBG, 4 points. You're not going to get that. I'm just giving one example. It's not the only example. I'm just giving one example of how, if we have technologists to help us, and if we had IT specialists to help us, they may not know anything about diabetes, but they know how to analyze this, they know how to bring this to some kind of a logical conclusion. Then we will be able to analyze it much better. For example, you can see here that this is type 2 diabetes, and you can see the time range is very good, virtually no hypoglycemia. So, there are other uses of CGM. It need not be only in type 1, type 2, finding out control and all that. We, many years ago, this is in 2019, for a trial on white rice and brown rice, we used CGM. Even the company had not approved its use. And they said, we don't know, this is not an approved use, it doesn't matter, it's not approved by you, but I am giving white rice to some people and brown rice to some people. These people without diabetes, by the way. They don't have diabetes, but I am giving them white rice and then giving brown rice. Well, let's see what the CGM tells us. This is one of the first applications. The company had not used it and thought about it, but we thought about it even at that time. Just see this graph. What you're seeing in red, the peak, this is non-diabetic people. They don't even have diabetes, they don't have pre-diabetes. They're eating the polished white rice. Zoom, the sugar goes high, and with that insulin also peaks. Now what you're seeing in blue is brown rice. We have prepared some brown rice, not polished at all, and pomegranate rice. Suddenly the peaks are much lower. When you see carefully, there are some blacks also. The black is when you add legumes and pulses along with the brown rice. So it's making it even more healthier. So this is one of the first illustrations. And then people started saying, hey, we can use it in non-diabetic people. Yeah, we can use this CGM. So CGM does not mean that only in diabetic patients you should use it. If you are creative, this is just one example. Maybe there are 100 other such examples where CGM can give. In fact, people are saying that using CGM, you may be able to predict heart attacks. And certainly we are going to look at complications. That's coming in the next slide. So in this is I think the last slide. So we're going to use AI, ML working with embedUR to understand the patterns of diabetes better, number one. Number two, to use CGM to predict complication of diabetes. Not everybody develops complications. Okay? And using HbA1c, it will give you a good, fairly good idea. Okay, if HbA1c is very high, your 3 months average is very high, these are people who will develop. You find people who have high HbA1c who don't develop complications. And there is a theory, unproven till now, there's a whole theory of Monnier from France, where he said it's not the HbA1c, it's the oscillations of the sugar, the fluctuations of the sugar which are keeping on hitting the cells, go up, down, up, down, up, down, and producing oxidant stress. It's now been proven, actually. We have the data now, okay, but we don't know how to analyze the data. So with embedUR, we'll be looking at, can you use the CGM using AI and ML? Once you train it, the first 5,000, 10,000, then after that you'll be able to say, hey, this is the person who's likely to develop complications. This will be a breakthrough in diabetes research, which we're hoping to develop. And finally, of course, we start with this, and then it doesn't mean only in CGM we're going to work. Then we take up something else, the next challenge. I think what we are entering into today is into waters where we have not swam before, but we are going to test those waters. And I am very confident that something new will emerge from this. And therefore, I think today is a red letter day in the history of diabetes research. I believe this is the first time that AI and ML are going to be officially tested for doing diabetes research. We did some Googling and saw how many people are using it. We use it in small situations like what I showed you, but this kind of an organized approach, I believe, is for the first time. And that's why we thought we should have a press conference to announce this. And with this, I would like to invite my friend Rajesh Subramanian to talk about how he thinks embedUR can help us.
This data shows the impact that MDRF is created and the impact that it's generated on people's lives. I mean, curing diabetes and reversing diabetes, this is going to be an excitement. It's an exciting start to a relationship that we believe is going to change the way we look at this disease using artificial intelligence and machine learning. Now, Dr. Mohan talked a lot about CGMs. CGM in a technology world is called a IoT medical wearable device. Internet of Things, IoT, medical, medicine, wearable. So, if you think about a CGM, a continuous glucose monitoring system that people wear, it's got two parts to it. There is a processor inside it, a microcontroller of sorts, that does the computation. And then there is Bluetooth, Wi-Fi. It uses Bluetooth technology to communicate to the device so it can send the sugar measurements. And then it's got a biology or enzymatic sensor which senses the sugar levels. So it's a combination of multifaceted technology that comes together to give us the ability to read sugar measurements. And with this, I'm going to give you a background on what we do and walk you through our journey. Yeah. Oh, this one. Oh, yes. Yes. So we are technology experts and a go-to partner for creating customized software solutions for our customers across all devices and all verticals. And that's what we do at embedUR. And I'll quickly go through the journey. We started the company in 2004 in Silicon Valley. And we actually continued to progress and established our Chennai facility. embedUR India was established in the year 2008. And we have continued to grow throughout these last 8, 9, 10, 11 years. And we have been supporting lots of customers in lots of different verticals, building software across many different industries. So we are a company that's been around for almost 20 years now. This July will mark the 20th year of embedUR. And the industries we serve, multifaceted industries. So we work on smart medical devices, we work on energy meters, mining equipment. What do we do there? We provide the software, we provide the connectivity, we provide the management framework, we provide support, maintenance of the software in different shapes and forms. Where are our customers deployed our software? All across the world. All across the world. This software runs on millions and millions of devices today, where we have developed this for our customers and they are deploying this all across the world, and we continue to support them all across the world. What do we do? So, it was 2 years ago where we said we are working on all these devices, we are working on connectivity, we are working on software. It's time, because everybody was talking about artificial intelligence, everybody was talking about machine learning. So 2 years ago, we almost started a separate group that started focusing on analytics, data, network control, and management, which is basically understanding volumes and volumes of data, trying to interpret them, and creating models around them, and then seeing if we can then use AI to predict what's going to happen in the future. I have to say something. We are now living in a world where I call this the Einstein moment. It is going to transform what is happening today in the field of technology. Is going to transform our lives completely over the next 25 years. We can't even imagine, it's unimaginable. Where this is the first time technology is ahead of what we can even think of doing. Because there's so much technology that you have to come back and figure out how can I use that technology to solve a problem. That's what we're trying to do with CGM data and diabetes. So this is the first partnership that we're embarking on, where we've already started using AI for a lot of different customers and applications. And this will be a very interesting joint partnership to make a difference. We are also very proficient in the edge. When I say edge, you can take the CGM as an IoT device, it's on the edge. It has compute power. It does computations. It then communicates. So we have engineers who have knowledge of understanding, collecting, and creating data models, which then can be used to proactively predict what is going to happen. This is our team. We have our VP of Technology and Head of Sales from the US also present today, and we have our Head of Engineering, Director of Engineering from India, and Head of Operations. All of them are present today, and it's a very exciting and proud moment for all of us. And we want to work together. This is a first start. It's a small start, like Dr. Mohan said. But I believe applying what we have learned in terms of edge, machine learning, and artificial intelligence, and combining that with the knowledge of the scientists and all those PhD students that Dr. Mohan mentioned, and getting this data is going to be truly transformative, and we believe this is one of the first, and we only look forward to making a lot of advancements in this area. Thank you.